Have you ever wondered how pilots stay in constant touch with ground control, even in the most remote parts of the world? From traditional radios to cutting-edge satellite systems, let's uncover the technology that keeps aircraft connected and safe in the skies. In this video, we'll explore key communication systems like VHF radios and satellite links, and see how they ensure seamless communication between aircraft and air traffic control, ATC. The importance of communication in aviation. Reliable communication is the backbone of safe air travel, enabling coordination between pilots, air traffic control, and other aircraft. Without effective communication systems, the complex air traffic environment would grind to a halt, jeopardizing the safety and efficiency of flights worldwide. Overview of communication systems. Aircraft utilize a variety of communication systems to maintain connectivity in the skies. Very high frequency. Radios. These radios operate on line of sight, providing clear voice communication between pilots and air traffic control for routine operations like takeoffs, landings, and in-flight instructions. High-frequency radios. For long-range flights over oceans or remote areas, HF radios extend the communication range, allowing pilots to stay in touch with ground control. Satellite communication, SATCOM. Satellite systems provide global coverage, ensuring that aircraft remain connected at all times, even in areas where traditional radio communication is not possible. These communication systems work together seamlessly, ensuring that pilots have access to the information they need to navigate safely and efficiently, while air traffic control maintains an accurate picture of the airspace. VHF radios. The primary communication tool, very high frequency. Radios are the most widely used communication tools in aviation, serving as the primary means for pilots to communicate with air traffic control. These radios are essential for maintaining safety and coordination in the skies, allowing for clear and reliable communication during all phases of flight. VHF radios operate within a frequency range of 118.000 MHz to 136.990 MHz, specifically tuned for aviation communication. The system relies on line-of-sight transmission, meaning that the signals travel in straight lines and are most effective when the transmitting and receiving stations are within visual range. This characteristic limits the effective range of VHF radios to about 200–300 nautical miles, depending on altitude and terrain. VHF radios are used for various applications in aviation. Routine ATC instructions. Pilots receive essential instructions for takeoff, landing, and in-flight navigation, ensuring safe operations in busy airspace. Flight information services. VHF radios provide pilots with critical flight information, including weather updates and air traffic advisories. Emergency communications. In case of an emergency, pilots can use VHF radios to communicate distress signals and receive immediate assistance from ATC. Despite their effectiveness, VHF radios face limitations, primarily due to the curvature of the Earth. This curvature can obstruct signals, especially at lower altitudes, leading to communication gaps. To mitigate these challenges, pilots often rely on higher altitudes for better line-of-sight communication and utilize other systems, such as HF radios or satellite communication, for long-range connectivity when necessary. Satellite communication, SATCOM. Staying connected. Anywhere in the world, satellite communication, commonly known as SATCOM, is the technology that enables global communication for aircraft, ensuring connectivity even over vast oceans and remote regions. This capability is crucial for maintaining safety and operational efficiency in aviation, allowing pilots to stay in touch with air traffic control, ATC, and receive real-time updates regardless of their location. SATCOM operates by transmitting signals from the aircraft to satellites orbiting the Earth. These satellites act as relay stations, receiving the signals and forwarding them to ground stations. The process involves several key components. Aircraft Earth stations. These systems on the aircraft send and receive data and voice messages. Satellite network. Satellites in geostationary orbits relay signals between AES and ground Earth stations. Ground Earth stations. Fixed radio stations on the ground interface with communication networks, facilitating the exchange of information between aircraft and ATC. This setup allows for reliable communication over long distances, unaffected by atmospheric conditions that can disrupt traditional radio signals. SATCOM is invaluable in various scenarios. Long-haul flights. For flights that traverse oceans or remote areas, SATCOM ensures pilots can communicate with ATC and receive critical updates. Remote region operations. In areas where VHF and HF communications may be unreliable, SATCOM provides a consistent link, enhancing safety. Emergency situations. In emergencies, when conventional communication methods fail, SATCOM can be a lifeline, allowing pilots to relay distress signals and receive immediate assistance. A notable instance where SATCOM proved critical occurred during a mid-flight emergency involving a commercial airliner. The aircraft experienced a technical issue over the ocean, where VHF communication was not feasible. Thanks to SATCOM, the pilots were able to communicate directly with ground control, providing real-time updates on the situation. This connection allowed ATC to coordinate a safe diversion to the nearest airport, demonstrating the vital role of satellite communication in managing emergencies and ensuring passenger safety. Data links, the backbone of modern aviation communication. In the complex world of air traffic control, data links play a crucial role in facilitating non-verbal communication between aircraft and ground stations. These digital systems transmit a wide range of information, from weather updates and clearances to aircraft status reports, reducing the need for voice communication and enhancing overall efficiency. Two of the most prominent data link systems in aviation are Aircraft Communications Addressing and Reporting System. ACARS is a digital data link system that has been in use since 1978, enabling the transmission of messages between aircraft and ground stations. It can be used for various purposes, including uploading weather information, downloading aircraft status reports, and exchanging operational data between pilots and their base. Controller-Pilot Data Link Communications. CPDLC is a two-way data link system that allows controllers to transmit non-urgent strategic messages to aircraft, such as clearances, instructions, and requests for information. Pilots can use CPDLC to respond to messages, request clearances, and report information. Data link systems utilize both VHF and satellite communication (SATCOM) channels to transmit and receive data. VHF is used for line-of-sight communication, while SATCOM provides global coverage, ensuring that aircraft remain connected even in remote areas. The process typically involves the aircraft's communication management unit routing messages to and from the ground. The messages are then relayed to the appropriate recipient, whether it's air traffic control, the airline's operations center, or another aircraft. The use of data links in aviation offers several key advantages. Reduced communication workload. By automating routine messages and clearances, data links free up voice channels for more critical communications, reducing the workload for both pilots and controllers. Clearer instructions. Text-based messages transmitted via data links are less prone to misunderstandings or errors compared to voice communications, ensuring that pilots receive clear and unambiguous instructions. With data links providing a reliable and consistent means of communication, the risk of miscommunication or loss of contact is significantly reduced, enhancing the overall safety of air travel. Redundancy and backup systems. In aviation, reliability is paramount, and multiple communication systems are integrated to ensure continuous connectivity. This redundancy allows for seamless operation even if one system fails. For instance, aircraft typically utilize VHF radios as the primary means of communication with air traffic control. However, should VHF communication become compromised due to range limitations or interference, pilots can switch to high-frequency radios for long-range communication or satellite communication, SATCOM, for global coverage. This layered approach ensures that pilots can always maintain contact with ground control, enhancing safety and operational efficiency. Pilots are trained to transition between communication systems based on the flight phase and location. During takeoff and landing, VHF radios are predominantly used for their clarity and direct line-of-sight capabilities. As aircraft ascend to cruising altitude, especially over oceans or remote areas, pilots may switch to SATCOM to maintain a reliable connection with air traffic control. In situations where VHF communication is unavailable, such as flying over vast stretches of ocean, HF radios become essential for maintaining contact. The ability to switch between these systems allows pilots to adapt to changing conditions and ensures that communication remains uninterrupted throughout the flight. The aviation industry is on the brink of transformative advancements in communication technologies. Digital voice communications are emerging as a key trend, addressing the limitations of traditional analog systems. This shift allows for more efficient use of the radio spectrum and enhances the clarity of communications between pilots and air traffic control. Additionally, improved data link technologies, such as the integration of ACRs and CPDLC, are streamlining information exchange, enabling real-time updates on flight status and operational instructions. These advancements not only enhance safety, but also make aviation operations more efficient by reducing the potential for miscommunication. Next-gen air traffic management. As these technologies evolve, they are paving the way for more automated and data-driven air traffic management systems. The introduction of space-based VHF communications will allow for seamless connectivity in remote areas and over oceans, where traditional ground-based systems may fall short. This integration of satellite technology with existing communication infrastructures ensures that pilots and ATC can maintain constant communication, regardless of location. Moreover, the concept of teleconferencing for ATC communications is being explored, allowing multiple aircraft and controllers to participate in discussions in real time. This could lead to more collaborative decision-making and improved situational awareness during complex flight operations. In summary, VHF radios, SATCOM, and data links are essential for ensuring smooth and safe communication in aviation, allowing pilots to stay connected with air traffic control and receive vital information throughout their flights.